Hey guys, I'm going to come to you now with the first lecture of magnetics. I'm recording this 5 days out or so. There's been some changes today. I'm assuming by the time you watch this video, it'll probably be, everything will be up to date. But it looks like we're going to be getting out of school in around 3.5 weeks or something of that nature. With that said, we're going to cut out some material. I know that you'll be sad that we're going to cut out mostly the calculations that come along with this, which are pretty hard to teach over a computer anyhow. So we'll be covering the rest of the units, but it'll be kind of abbreviated, obviously. So we're going to do magnetism and then electricity and magnetism together. And then we'll get into our final unit, which is supposed to be energy sources, which is, unfortunately for you, you missed it. That's probably most of my students' favorite unit. But we'll spend the last 2 weeks or so on units we'll spend the last 2 weeks or so on the unit of energy sources. And that'll be looking at alternatives and fossil fuels, both renewable and non-renewable energy sources. A couple people have emailed me and asked about turning assignments in. As of right now, I'm just collecting the checkpoints still. My original plan was to have you use your guided notes and your worksheets to take open notes tests, but that's not going to happen now, it sounds like. So watch for something on the website about how we're going to finish up grades, but most of it will probably just be those checkpoints and the Rube Goldberg project or the alternative assignment that some of you did. But again, most of your grade will be based on just doing those checkpoints on Fridays. So let's get into magnetism. So magnetism is defined as the properties and interactions of magnets. Magnetism is the properties and interactions of magnets. It's kind of like this, it's not the study of, but kind of like the study of magnets and how they interact. And yeah, we're using the word in the definition. We're going to define magnets more in a minute here. But understand that it's just how they all interact. And we're going to look more in the next lecture on how magnets and electricity overlap and the electromagnetism. Right, so first of all, a magnetic field is an area that where a magnet exerts a force on other magnets and magnetic materials. So a magnetic field is where a magnet exerts a force on other magnets and other magnetic materials. And that's usually going to be stronger closer to the poles. So the closer you are to the poles of a magnet, the stronger that's going to be. Right? So magnetic poles are the polarized part of the magnet, north and south. So every magnet has a north and south, and they can't be separated. We'll come back to why in a little bit. But magnetic poles are the polarized part of the magnet, north and south, where the magnetic field is the strongest. Where they are located really depends on what type of magnet you have, what shape it is. For the sake of simplicity of teaching this on NTI, we're going to stick with bar magnets for today. So let me pull out my pencil here. So if I have a bar magnet, a very simple bar magnet, and I call this north, and I call this south. All right. So every magnet's going to have a north and a south. They can't be separated. And again, we'll come back to why in a minute. But every magnet's going to have a north and a south. The magnetic field lines are going to go out from the north and into the south, out from the north and into the south, out from the north and into the south. Now, if we were to put another magnet near this, you would see these attracting each other. But they're always going to go out from the north and then point into the south. And the strongest part of the magnet is going to be right by the poles. Okay? Those are our magnetic field directions, out from north into south. Now, let's talk about the history of magnets really briefly. So magnets were initially discovered, as far as we know, historically in Greece, in an area called Magnesia. That's why they're called what they are, in a mineral called magnetite. Now, there are three naturally occurring magnetic elements: iron, nickel, and cobalt. We usually use iron for most things in labs because it's easy. But iron, nickel, and cobalt are the naturally occurring magnetic elements. Now, other elements can be magnetized in different ways. So if we run electricity through copper wire, it becomes magnetic. That's critical to the overlap of electricity and magnetism we're going to study in the next unit, in the next lecture. But the three that occur naturally are iron, nickel, and cobalt. And so one thing that's kind of weird has to do with the Earth's magnetic field. So the Greeks discover that there's magnetism because they realize if they hang magnetite on a string, that it always points the same direction. So they would hang it on a string and it would point one direction. Now, what we call the North Pole geographically. So the North Pole that we're used to calling the North Pole, it would point that way. What the Greeks didn't understand is how it worked. And so what they would do is they would call that the North Pole because the north part of their magnet faced that way. Well, what's very elementary that most of you know is that opposites attract, right? So if the north part of the compass is pointing that direction, that must be actually south. So it's kind of weird, but the Greeks labeled it backwards. So what we call the North Pole geographically, what we always call the North Pole, where Santa Claus lives, is actually magnetically the South Pole. And the South Pole is actually magnetically the North Pole, because the Greeks didn't understand why they were calling it what they were. So those are kind of flipped. Now, let's get back to how the magnets work. So magnets are usually iron, nickel, and cobalt. They're made of domains. So domains, magnetic domains, are groups of atoms with aligned magnetic poles. Groups of atoms with aligned magnetic pole. So when we say a material is magnetizable, what we're really saying is that the domains can be aligned. We can put those in one direction. Now we can make magnets by we have a machine at school called a magnetizer, but by running electricity through them or putting them near other magnets, we can magnetize things. Iron, nickel, and cobalt, that can be done very easily. All right, so I have a food-covered toddler looking at me through the glass. Hey, buddy. So magnets are actually made up of these domains, and so this would be very, very zoomed in, but I'm gonna, for simplicity's sake, only put so many on there. And so each of these little boxes that I've drawn here is a domain, a group of atoms that are aligning. And what's actually true is that each domain has poles, north, south, like that, and so on and so forth. And so they're all aligned, where the north end of one domain is lined up to the south end of another, and so on and so forth. And so if we were to actually split this magnet, let's say we split this magnet right here, you would find that you have two new magnets, where these norths are on one end, north, and these souths are on the other end here, and the same is true here. And so when we break a magnet, we now have two magnets, both with north and south. So we can never separate the north and south poles. Hopefully showing those domains lines that up for you a little bit. That is all on the intro to magnets. I'll see you guys next time with electricity and magnetism.